Hi, we're excited to launch a new Android app for your phones and tablets. It's built specifically for professional field geologists. So how does it work? Launch the program and create your first project. A Google snapshot is displayed on the screen, and while there is an option for GPS positioning, we will demonstrate working locally here. Add a project and give it a name. The project boundary can be imported as a vector file or defined manually. You can change the line thickness and color. Please adjust the frame manually. If the coordinates are known, specify them numerically. The project is ready. We can start. For every type of load on our future map, you will need to create a separate layer. Please be sure to give each one a descriptive name. Your layer has been saved and has now appeared within the window. Clicking on the arrow will expand the entire list of objects that it contains. Clicking on the eye icon will toggle it off and hide it from your view. Now let us move on to the process of creating a new path. In the pen tool menu, add a path and then select the line type, its color, its thickness, and its final design. And let's try to draw something out, shall we? Now let us take a closer look at the list of layer objects. You will notice that our contour has now appeared within that list. We have the option to smooth it out by using the spline button, add, remove, or reposition individual vertices, close the contour shape, or simply delete it entirely. Now let us move on to geology. We are creating a contour map of the modern quaternary alluvial deposits found in the river floodplain. Please go ahead and draw it. First, go ahead and smooth out the edges by utilizing the spline button located in the main toolbar. After that, take a moment to carefully adjust the outline wherever you feel it is necessary to achieve the perfect look for your design. Next, select your preferred fill color and adjust the opacity settings to your liking, and then finally go ahead and fill it all in. We are going to select the hatch. We will show you how to create it later on. I am going to change the hatching color to black right now. Please crop the contour so it fits the project frame. The title also needs to be aligned with the instructions. Set the correct casing in the text and italics if necessary. In our case, we are only changing the casing. The contour is ready. We are creating the adjacent contour. This is an older first supra-floodplain terrace composed of a mixture of alluvium and proluvium. Drawing the outline. Smoothing it all out. I'm changing the fill color. I'm changing the hatching style. Editing the caption. Let's move the title wherever we want. We subtract the contour of the younger deposits from the map. Please note that this is actually quite simple to accomplish. I'm cropping it to the frame. The outline is ready. We create a separate layer to store our observation points. Note that the program keeps the preloaded Google satellite imagery in the cache until it is restarted. So, while at camp where there is internet, you can download the area you need to your device by zooming and panning. And even if there is no internet on your route, you will still be able to see the map image and your current location. You can also upload any georeferenced aerial photo, map, or topographic surface to your project. You can set a point using GPS or by simply clicking on the image if you are sure of your location. We are placing it. You should select the point symbol and also choose its color. You can add a note to any point, and you may also attach an image file, a photograph, an audio clip, or a video file to it. Or you could just go ahead and write a comment. That is settled. Let us move on to the next. I am setting a new point right now. And one more very important and necessary capability. The program can construct fault planes, and this is the first step toward 3D modeling from 1, 2, or 3 points. It can also do it from a line drawn by a geologist on a map, but in that case, it is unlikely to produce an accurate plane. Faults like these are rare in nature, therefore we will set this topic aside for now. However, we are now going to try to construct faults from points. At our first point, we identified a fault and measured its orientation using a geological compass. Far from a precise instrument, by the way. We got an impact azimuth of 270 degrees at a 70-degree angle. Once these specific parameters were finally set, the program instantly generated the projection line of the fault plane onto the surface. And if you decide to change the input numbers, the line updates just as quickly, which means it is now entirely possible to adjust the accuracy of our tectonic models right out there in the field. That is truly fantastic. We then moved up the slope along this fault and placed a second point on it, which allowed us to construct a plane using those 2 points. At this point, we need to specify at least an approximate dip azimuth, since there are 2 possibilities, one way or the other, and the program calculates the computed azimuth itself. And you are required to set the dip angle right here. The configuration of the plane line on the surface also depends entirely upon it. And now we have successfully obtained another line with orientation elements that are quite close to the first but significantly more accurate. We went further along the fault and placed a third point on it. Since only one plane can be constructed from 3 points in space, there is no need to define anything else. This is the most reliable method, with some caveats of course. Positioning accuracy and the level of detail of the topographic base used to build the surface model are crucial. And so we arrive at the third line, which is the most reliable one. So we're removing the previous 2. There it is, our fault. It's a real beauty. We continued along the ridge and managed to set our 4th point. There's another fault there too, a south-dipping thrust. We are currently plotting it from a single point, using the strike and dip we've estimated by eye. It turned out too shallow. It doesn't fit the terrain. Changing the angle of incidence. I must say, this is really quite good. It manages to reach all those hidden nooks and crannies. We have decided to take it. I am changing the line type. Thrust faults use teeth that point in the down-dip direction. And this thrust fault truncates our first fault, so we cut line by line and remove the unnecessary piece. We made our way down the slope to the west. It was there that we discovered another fault line. We marked points 5, 6, and 7 along it, constructed the feature, and intersected it with our thrust fault. A geological contact runs right along this newly identified fault line with an igneous intrusion situated to the east and a layered sequence located over to the west, which needs to be clearly marked with a strike and dip symbol. To do this, create a new layer bedding elements. Make it active. Yes. Navigate over to the Tools menu located at the top, then select the option labeled Add Bedding Element. Next, choose the normal bedding point symbol from the list, and finally enter the specific measured azimuth and dip angle values. Place a point on the map and you're done. The element icon is rotated correctly. We are adjusting its color and the position of the text. Now we will move on to outlining the various rock formations. At this moment, I am drawing a solid block of granite. I am painting it now. I am trimming using the folds and the adjacent contours. I am currently formatting this title. The block right next to it shares the same border style. I am drawing an outline, and to avoid having to format it all over again, I am using the copy properties function. I have finished copying both the fill and the text style. Now I am trimming the path and it will be ready shortly. And now it's time to introduce you to the constructor. With it, you can create your own point, line, and hatch types. Here is how you can hatch with points. Let's create a symbol for granite in the constructor. A cross. I will apply it using points. But first, I am going to create a new crop layer and then I will set it to be active. I am officially making the first point. And then I just go ahead and copy and paste everything using the buttons. The granite is ready for you right here now. You are able to create custom line and hatch types directly within the constructor interface. Here is an example of one of the hatches, which was drawn quite quickly and easily using the pencil tool. This version was also created with the pencil, but with the auto-correction feature enabled. This is exactly what oblique hatching is supposed to look like in practice. Take andesites, for example, they can be drawn using a line while adding a slight curve to effectively represent the internal layering. We must also include the conglomerates. I've performed a bit of magic here while you were away to save us some time, and I have created this geological map. Now we need to save it permanently and send it over to our colleagues so they can make use of it. For this purpose, the program includes a project export feature. To do this, go to the Projects tab, select your current project, click the three-dot menu, choose Export, and set the file path. The file name includes the export date and time, which helps with organization. It's that simple and easy to create geological maps of any complexity right in the field, with virtually no office work, and the developers are constantly expanding the functionality. Plans are underway for a quick transition to volumetric modeling with reserve estimation and resource calculation. So let's wish them luck and look forward to good news.